Hello and welcome back to the channel. Today we're at Blackcore Technology and today they're talking about their high frequency trading server technology. Let's go check it out. Hi James, nice to see you. Congratulations.
Thank you.
On the recent promotion to MD.
Thanks. Do you want to come see how we build some Blackcore servers?
Let's do it.
Thanks.
If you could talk to me about the technology, can we dive in a little bit deeper into systems and find out exactly what they do?
Sure. So Blackcore provide overclocked liquid-cooled server systems for the electronic trading industry. So we have a custom-made server chassis. These are built and designed in the UK. And then inside of that we have various components like the power supply, SSDs, motherboard, CPU, memory, and network cards. When you're overclocking, you're pushing components harder than they're meant to be. So we're increasing the clock speed and we're putting more power into those components. That means they generate more heat. So having the system designed in a way that can handle all those extra parameters is really important. So we have a custom liquid cooling loop. We have a custom power supply designed to deliver that high power. We also have to evaluate the motherboard and other components to make sure that they can deliver high power to the CPU. So for example, a 60-core CPU might be rated for something like 300 watts, but when we overclock, we push that to something like 900 watts. So there's a lot of extra power that we have to put into the system, and there's a lot of extra power that the power supply and the motherboard have to be able to deliver cleanly to make sure the overclock is stable.
Brilliant. And I've heard a rumour that I'm talking about binning CPUs.
Yes.
Is it right that you could look to throw away every 2 and 3?
Yeah. So every CPU, even if it's the same model, so you have a bunch of 60 cores, they're all the same model, they are not all made equally, so each one has its own little tiny imperfections, and that limits the amount of overclocking headroom that each CPU has. So part of what we do is thoroughly test each CPU to make sure it can hit our overclock targets, and part of that comes from the product development process where we're finding the limits of those CPUs and how many of them on average can hit the kind of speeds that we need. Over the years we've really improved that process through our experience, our knowledge, our testing procedures, our cooling, etc. And so now we have a much better bin rate.
Brilliant. That's really good. And I see you've also got some Micron SSDs on display there.
Yep, so we use Micron for our SSD platform and also for our non-overclock memory platform. So for our overclock memory, we actually have some custom DDR5 made. So, nice branding,
slick.
We spent a lot of time when DDR5 came out trying to tune these for low latency. When DDR5 first came out, it was a lot higher latency than DDR4 at the time, so it was a much maturer platform. So we really spent a lot of time working with a vendor in Taiwan to cherry pick DRAM chips that could achieve the kind of speeds and latency that we were after. And we also had to work on the thermal cooling of those chips, because when you overclock them, they do get very hot.
Brilliant. I noticed as you did that, you've got some kind of bracket here with your logo on it. What is that?
So we actually 3D print these and designed them in-house. So these are just a simple sort of toolless bracket that goes over the memory and has a fan on. This reduces our temperatures by about 20 degrees.
Wow.
And I can show you our 3D printing area.
Let's do it.
So Tom is the lead of our product development team, and he introduced 3D printing to our processes. So we now use it both in our product development process, but also our production process. Tom can tell you a bit about why we do that.
So we are using PETG V0 Proof Jet Black. It is a filament that is UL certified with a blue card. It allows us to print any component, assuming we follow certain parameters, and it's immediately certified. This helps us massively with the certification of the entire system, because everything in our system needs to be certified. It allows us to iterate rapidly on different products. We've had in the past queries on custom cooling for certain PCIe devices. We've been able to print and deploy these cooling brackets to these specific customers that requested them within a few days. That's held retention for some of our customers. We've got plans to expand the print farm. We are making faster printers. We've got other printers for prototyping new designs. This is a bezel design for one of the 3 Blackcores.
So what that means is we can test out new things, new adjustments to the chassis, new bracketry, move components around really fast, and within a few days we can have a design finalized before we send it off to be made in metalwork, whereas previously we had to wait weeks to get something made in metal before it would come back. We could verify it, do adjustments, and go back through the process. So it's really helped us rapidly evaluate and evolve our product development processes.
So following on from what we were talking about earlier, we've got this lovely machine here, it's the belt printer. He's able to produce long parts and also continuously print multiple small objects. So this component we have here is a rubber grommet that sits on our server bays. It's used to cover the male thread that could scratch the system, so that just keeps everything nice and pretty. We've got some ducts here that we were iterating with the Flex product to determine if airflow is adequate or not. We had a bunch of different duct designs we went with, and we decided which one was the best. We've also got tools that I print for production. We have liquid metal templates, just little jigs to do drawings. This one is a funnel that is designed with special ducts that let air go in and out so we can fill the loops quicker. And then we have over here, we've got a scenario where I needed to test fit a card, but I didn't want to keep using the expensive card and breaking it, so I just printed out another one for fitting purposes.
So one of the key parts when you're overclocking is the testing process.
Yep.
When you're pushing these things beyond their limits, making sure that they're not going to fail and they're in acceptable temperatures and voltage ranges is really important. So we spend a lot of time figuring out the safe window for the voltages and the temperatures and the power draw whilst we're doing our product development. And then once we're in production, all of the systems have to pass some very strenuous testing, and there's a certain amount of hours they have to pass within those temperature and power limits.
Okay.
That really ensures the reliability of the product. So that's something we focus on at Blackcore, is the reliability, and there's no point having the performance if the system's going to crash every couple of weeks.
The most important aspect. No, completely agree.
Yeah.
Okay, great.
So shall I show you the testing area?
Let's do it.
Cool. So we have a kind of a small little data center setup with a bunch of different racks. They're custom made racks so that we can quickly get units on and off. Makes it much easier for the guys to move things around and diagnose, etc. as they're testing. And all of the KVMs are remotely managed, so they don't have to sit in here to do the actual testing. They can sit remotely in the test area and log in and make sure all the stress testing is going okay.
Brilliant. And how long do you typically test for?
So all of our systems are tested for a minimum of 16 hours. Normally there's 2 sets of 16 hours. So one will focus purely on the CPU and the other one will focus on the memory and the cache on the CPU. So checking the link between those is stable.
So a lot of checking.
Yeah. It's really important to make sure that they pass the testing. That helps us ensure that A, the system's going to last the lifespan of the warranty, but also it reduces the amount of DOAs that we get when delivering products to customers.
Yeah. Looks good as well. I like the logo.
Yeah, the green light's really important. Really sets it apart. So after testing, the products come out to the dispatch area. So here we do final checks on the systems, make sure everything that's meant to be in them is in them, check that everything is installed correctly, no loose components,
Yep.
and then box and ship.
Wow. Just like that. It's all done. James, that's been brilliant. Thank you ever so much for the tour. I really had some insights today. But talking about more real-world examples, how does what Blackcore do give your customers the competitive edge?
So obviously our focus on performance is one key area,
Of course.
but our focus on the quality and reliability of the systems has really changed the overclocking server landscape. So, you know, a long time ago, it used to be a much more kind of risky piece of equipment to put into your trading stack. But the work we've done to bring failure rates down has made it kind of the go-to choice for any electronic trading. And we're able to provide, you know, that performance and that reliability, and it just reduces the risk on the overall technology stack. And obviously, we talked a bit about the product development process. We're always looking ahead of what's coming next. You know, what are the new CPUs available? What new technologies are happening in the memory market, or maybe you know, the network market? Maybe it's photonics, etc. And we're looking at how can we implement that into our systems and give our clients the next edge.
That's brilliant. Absolutely brilliant. Really insightful. Thank you.
Oh, you're welcome. Thank you.
So guys, that's a wrap. I hope you enjoyed the tour and insight into Blackcore Technologies, and I'll catch you on the next one. Thank you.